The Reconceptualising Maths and Science Teacher Education Programs, or REMSTEP, responds to the need for improved competence and confidence in the teaching of science and maths as a pre-service focus across the Australian curriculum. At La Trobe University, REMSTEP is working in partnership with the Faculty of Education, science researchers, featured science centres across Victoria and school communities to support a newly developed M-Teach course for pre-service teachers.
A lot happens in grade 5 and grade 6 that sets people on a path to or from science. And we've been tasked and funded by the chief scientist to try and do something about the infamously leaky STEM pipeline. Because at the moment, when a whole bunch of people in their 50s retire, Australia is not going to have anywhere near enough people who are scientifically and technically literate in order to create the industries and companies that Australia is going to need to be secure. What we would really like to do is try and understand more carefully what happens when a scientist is doing something slightly magical with young learners and try and codify that so that when magic does happen, it happens every time. And those are core to what we're trying to do with integrating REMSTEP with these teacher education programs.
By introducing our students to science researchers and making our labs and equipment accessible to participating schools, our pre-service teachers can conduct authentic scientific experiments with their students.
REMSTEP started the whole thing for me last year when I was given the opportunity to create my own experiment that I could do in a primary school. Originally that setting was designed for me to go to a scientist, learn what they were doing and teach a part of that to my students, but it was not going to work in a million years. REMSTEP came to the party by providing all the equipment, which I could never have done on my own, particularly as a pre-service teacher. They gave me information when I needed information. They looked through my experiment and they were there to make it all happen.
Toilet, urinal.
I think the REMSTEP project, by pulling scientists in together with pre-service teachers, has the opportunity to build everybody up and show the kids that it is exciting and everyone can get into it.
Through the establishment of a virtual laboratory network, La Trobe now offers access to state-of-the-art facilities and world-class research directly into our schools to engage high school students with science and maths nationally. FAR Labs, or Freely Accessible Remote Laboratories, has been funded by REMSTEP to continue supporting secondary school science programs.
We're using turntables from La Trobe University and we're experimenting with alpha, beta and gamma radiation.
The benefit of things like FAR Lab for teaching students is that they allow us to take students on journeys that they could never do sitting in the classroom. But imagine when you're in a position when you can actually control and make decisions and ask questions. When you do that, you're in a position where students can actually take steerage of their own knowledge and learning. What can the teacher do? Well, we can facilitate that process. We could provide them with the challenging questions. We could make connections with other things that they understand. You get that immediate feedback and a sense of ownership. I was part of that experiment. I helped steer it. I made a difference. Without it, the lesson's a lot shallower.
There are a lot of interesting things happening in primary education and teacher training already in La Trobe University, in particular in the regions. And there's one in particular which is called MISTI, which is Multidisciplinary Science Teacher Integration Education. And it forms part of the teacher training for primary teachers. Now we saw an opportunity here for engaging the pre-service teachers with practicing research scientists.
Olivia and myself have been working with Year 1 students at Girton Grammar, and we have been focusing on physical and chemical change. We asked David to come to Bendigo to help us with the liquid nitrogen. Because we were so involved with making crystals, we also told them that that was his specialty. So that really guided some of our questions.
So how did the crystals form? That's the question.
For children to see a real live scientist in operation has been a wonderful experience for them, and it has further expanded and consolidated their understanding of the topic that we're studying.
To support REMSTEP sustainability, La Trobe University has been collaborating with 2 currently funded Australian Mathematics and Science Partnership programs, Into Science and Growing Tall Poppies. These projects will continue to engage pre-service teachers in the teaching of maths and science through innovative partnerships between schools, universities and community organisations.
Being involved with the Growing Tall Poppies program has really powerfully influenced how I'm thinking about teaching and going into next year, because I've seen how much students can change, how much engaging with the science and with the scientists can change them and have such a positive influence on their outlook.
There are many problems in the real world that affect us on a very tiny scale. And just like through this project, we investigated how we can measure hair using light diffraction and just seeing the surface of hair.
That's probably what I've really enjoyed most out of the program, is seeing these kids develop. How on the first day they were like, I don't know what science is, I don't really like science too much, to I can see myself in a career in science. And that happened in 2.5 days.
I might not necessarily want to become a physicist, but I want it to be a part of what I do.
Science no longer seemed like this far away, difficult thing that only some people can do. It suddenly became something that anyone can do and anyone can enjoy.
Teaching science is a compulsory second-year subject at La Trobe. We have an interface with the Discovery Centre here in Bendigo, as well as 4 local schools. What that gives us is another opportunity for our PSTs to interact with the Primary Connections material in an environment where it's more realistic. So it's in a classroom setting for engage phase, at discovery for the explore phase, and then they also include a technology element in an elaborate phase activity as part of that assessment. What do you think you've gotten out of the program so far?
I would say it's lessened my fear of teaching science.
We're really excited about bringing the pre-service teachers into here. Something else we aim to do in these labs is to model good practice. So we do these labs for a variety of different age groups, but every time we do the lab, we're picking specific words and giving them the extra scientific content, the scientific language that they're going to use in the years going on beyond that. And I really want the pre-service teachers to take that on board and think about how they are engaging with their students as well.
Slime is the bits of corn flour and the water all kind of floating around together, really. Now, it's got a special name of a stir thickening fluid or a non-Newtonian fluid.
Being a pilot, which involves La Trobe, the schools and students, and also Discovery, is that we're also working with REMSTEP. And so they're bringing in a whole different perspective, which I hadn't necessarily thought about. This time we're going to have some professional evaluation, see what we've done well, but also where we can improve the messaging that we're doing, and also improve perhaps some of those ways that we are engaging with pre-service teachers, which is kind of a new audience for us.
What we're concerned about is how do we make this sustainable when the funding for REMSTEP is no longer around to support it. We've realised that this is an incredibly powerful way of aligning existing outreach programs, which are well resourced and a core part of the university's business, with the other core part of the university's business, which is training teachers and training undergraduate students and training postgraduate students, all to be effective communicators in science. It's not that difficult. The key part is making sure that scientists understand that their contribution can seem to be very modest, but be very, very powerful. That's a nice observation.